the methane that's in the pore water can be either solid or gas. And so we're looking for the solid. And yeah, I'll leave it at that.
Yeah, that sounds great. That's really interesting to think that it is exposed here in the canyon because of that deep carving canyon exposing. So is there a sense that in other places hydrate is buried beneath several hundred meters of sediment and that's just where it is it's kind of like tucked in there, but because the sediment hasn't been removed, we haven't seen it? Is that?
Yes, well, in seismic records, which is what we use to look beneath the sediment surface, the seafloor surface, we can see what's called a bottom simulating reflector, which just is sort of a cap where at that point, beneath that point, the gas will be in the pore fluids, but it can't escape beyond that because of this hydrate layer, basically. Unless there are faults or fractures that allow the gas to escape, or else the gas will migrate along that solid hydrate level to 500-meter depth, and then it will be able to egress out of the seafloor. So unless there's something that disrupts that, we generally don't see this hydrate exposed.
Do we know if the hydrate's actively forming in this region, or is it all existing and just being exposed?
It wouldn't be actively forming on the seafloor at this depth. Yeah.
Where does it form?
It forms. Where does it form? And why does it form? Is kind of that's a good question. But that's what we see in the seismic record is this and that bottom simulating reflector is much deeper than 500 meters.
Okay.
But it sort of acts as a cap, like I said, to keep the gas phase of the methane below it or above it. So the methane bubble streams that we see that are less than 500 meters are probably formed by just biogenic processes from bacteria, eating the methane and in the pore water. And the hydrate sampler is actually, we're trying to collect hydrate to figure out whether or not that methane was formed from biogenic processes or from thermogenic processes, which are things that happen much deeper. The heat that forces the methane up towards the sea surface, well, the sea floor. So, and that is sort of a convoluted explanation, but
no,
I wrote a paper on it and I'm still trying to understand it. So luckily I had some help. Paul Johnson, are you there? Bob Embley, are you there? I had some good mentors that I've worked with through the years, and I'm hoping to hear from them. And we do have a portal where scientists can write in and help us out if we have questions we can't answer.
Susan, folks want to know, how long can the methane be trapped for? Little squid just went by.
I think that's an answer that we still don't have. And I think that maybe these hydrate samples that we get can help to answer that question. There's still a lot we don't know. But we do know that, these processes have been going on for, thousands of years, like the carbonates that we see is basically these bacteria or methanogens, which are similar to bacteria. They oxidize the methane and it precipitates these large amounts of solid hydrate deposits at the sediment seawater boundary. And those things take thousands to tens of thousands of years to form. So, I mean, these processes have been going on for eons, you know.
Absolutely. Yeah, when we were looking at Carbonate Ridge, if you were with us on our previous dive 2 days ago, that the scale of that Carbonate Ridge, you know, kilometers long, I don't know, about 40 meters high, didn't figure, maybe somewhere in that ballpark, that we jumped up onto this long elongated elf. Jeff was estimating, you know, we were looking at hundreds of thousands of years of carbonate precipitation to form a rock structure that big. And then, you know, the history of that, the physical structure of the seafloor then starts to create lots of other dynamics, change the currents in the area, attract sea life, create habitat where things like corals and sponges or anemones can settle and grow.
Yep.
I actually tweeted about it because I was thinking about it after the dive the other day, but thinking about so often I think people think about science in like one specific ology or orography at a time. And I love doing this work because you get to see it all slam together. You know, like at Carbonate Ridge, you were seeing a chemical microbial process from teeny tiny methanogens literally creating rocks, so creating geologic structures that influence the physics of the water movement. That's your oceanography, that attract your biology, you know, that create your fisheries, that create like questions about how we manage the ocean. Like, I love the ocean because it very quickly slams everything together and you have to see it as a system.
That's the group that I work for, the Earth-Ocean Interactions Program, which was formerly the No Events Program. Have as long as I've been working there for 24 years, we've been going out to sea with multidisciplinary groups because no one person can know everything. So yeah, we go out with biologists and geologists and chemists and physicists, and so that you can gleaned all of their experience. You know, more eyes are better than just two, and that's the beauty of working with remotely operated vehicles, is that you can have all of those people in there watching the same video at the same time and discussing what they're seeing, rather than one person going down in a submersible, you know, and typing up a little report of what they saw, and then later you get to see the video. So I think it's a really wonderful way to work. When I first started here, they had just kind of given up on going out and submersible dives, and I'd always wanted to go down in Elvin, you know, and my boss was like, well, we really like these remotely operated vehicles. They're so much better. And as I get older, I don't think I want to go out in a submersible anymore, you know.
Yeah.
This is the way to go. You don't have to get wet to be an oceanographer.
Absolutely. And, you know, and what's exciting about this technology is I know oceanographers who don't even go to sea, you know, for the reason, any reasons that they don't want to, that there are different things in their lives. So, you know, I think this technology is really opening up the ocean to let people experience it in different ways and collect their data. You know, if you have a particular sensor that's going to dive on a particular dive, like for 6 hours, you know, you don't need to take a month of your life to come to sea to do that. You know, you can be here, you know, everyone who's tuned in watching, well, and you're seeing the feed live. Like,
well, and that's what the beauty of the live feeds now. You know, I have friends I know that are watching from shore that are retired, but just love the remotely operated vehicle work, Hercules work. Hi, Andra. But, you know, she watches all the dives just because she loves the ROV work. And it's fantastic.
Hello,
we're getting close. Ah, there's the seafloor. And our first objective is going to be to poke around and to try to find that marker 273 that was deployed in 2016 next to the hydrate at that time, that was exposed at that time.
That marker number, there's not 272 other markers, are there?
Well, there are, but they're just not out here.
Those are nice markers.
Yes, they're made by Pacific Marine Environmental Lab engineers. And we have them all over the world, from out
Nice.
here to Axial Volcano to the Marianas and Northeast Low Basin, anywhere we dive.
Yeah. I don't think I've seen one at Axial before. Maybe they're a new thing.
You haven't seen one at Axial? Oh my gosh, we have
When did
tons
they
of,
start going in there?
about 30 years ago.
Huh. I've never
Yeah.
seen one there. You usually see the bucket lids.
Those are Delaney's. No, we have the nice markers. That's University of Washington.
Or the flamingos.
Yeah, that's Ambari.
I think they stopped doing that.
They did. No, I'd say we probably at Axial on the Juan de Fuca, we probably have 100 markers out there.
Wow.
They've gotten better over the years, so.
Well, that's how I was saying the numbers cut through them. I haven't seen those before.
Yeah, that's a little fancier. They've gotten better.
They looked, I mean, we did 262 yesterday, and I just couldn't stop thinking about all the like marathon folks. And I was like, this is your moment, you know, all the like 26.2 bumper stickers and t-shirts and everything. I was like, okay, we'll call you this marathon methane season.
I think we got about 100 of them in our last shipment from the lab, so we don't pull them out in
yeah,
order.
they're not sequential.
Yeah. That would take a lot of time.
Mm-hmm.
And you know, when we're out at sea, we don't have that much time. We just use up a box at a time. Okay, lots of, what are we seeing out there, Taylor Ann? Our biologist and scientist.
So I'm seeing lots of
enable.
sea stars, and I see some Rathbanaster sea stars, ones with more arms. Can't really see too much from this far.
Yeah.
Other than that, it looks like a really soft bottom, though.
It is. There's a lot of sediment out here, obviously.
There's a lot more stuff in the water column, too, as you can
Yeah.
see in our scaling lasers.
Yeah.
Okay.
Lighting it up.
And those lasers are 10 centimeters apart?
So blue light, and then wait for, yeah.
At some point, Tim, do you want to help me set up the stills cam?
Okay.
So 10 centimeters is about 4 inches apart for all us U.S. folks who never went to the metric system.
Hi, viewers around the world joining us. We have folks in Serbia, Bulgaria, South Africa, Sweden, Singapore, Philippines, United States, Canada, Finland, France,
Wow.
Spain, Denmark, Austria. We're thrilled you're all here. Hello in Macedonia. We're going to get all set up here on the seafloor, which is the navigator getting the vehicles strung out in position, and also the video camera's white balance.
On the shoulder.
We'll also get our stills camera set up by...
Is that the porch light on, pilots?
Yeah, it is.
You can turn it off. That actually is.
Frozen.
Yeah, I can't hear you, Bob. I think you're asking.
Bob, you're not on SBL. Oh.
Were you force talking video?
He's talking a video.
Huh. Yeah. Okay. Coming in. If you get porch light off, that'd be helpful. Yeah, there we go. Thank you.
We're all set for you to come back on SPL whenever. Do that right away.
All right, I'm going to go ahead. Black balance is going to take the cameras dark. It's intentional. Going to take about 5 seconds starting now. All right, 10 seconds. What's the difference?
And if the still cam is not on, can we fire up the still camera when we get a chance?
It is
Good
on.
black balance.
Yep.
White
it's on.
balancing.
Sweet deal.
Straight up and down is a good white balance. White balance is good. Full range of focus. I did.
Are we focusing the still cam?
I think there's still
yeah, Tim, do you need the arm out there to focus the still cam?
Yeah, we will.
Okay, roger. Let me know when you're all set.
I think you need to bring it up and then stretch it out some more.
Okay.
Bring the
Shoulder.
wrist around, I guess. I don't know. I guess you gotta
Shoulder up?
Yeah, a little bit. Just bring the wrist over, I think. And maybe, I don't know. You can close the grip, just close it and then
Lock it.
hit your lock. Yeah.
Oops.
It's always a good idea to check your consolette there to make sure it's locked.
Okay.
Right?
Yeah.
It's a good habit to get in because then you know you have it locked.
Yeah.
You know, because if you just assume and you let the thing off, it's like you drop whatever you're holding.
Yeah.
I always check. So.
Okay. Okay.
And then so then you can freeze it if there's not much coming from there, but
okay.
So yeah.
Well, I'm left-handed.
Yeah.
So I
right.
I cheat it this way. That's why I forget to look.
Right.
But we could put it on this side.
No, we can't.
The question, do the ROVs get dirty? They get sprayed off after every dive.
So Tim, are you happy with the focus on the sextant?
Tim's off a headset. Taylor Ann, are you? What do you need?
Still working on it.
Okay.
Are we drifting up some? What's happening?
Me?
Oh.
No, I'm still at 3 meters.
Okay.
Hi.
I had a question for you. How often do you have to replace that white balance tape? Do you have to clean